right? So we're talking about how is light, how is that actually energy? What is that? How does that make sense? It's just these particles being emitted. Well, because those particles are moving, they're very highly energetic. What are those particles? It can be a collection of protons and neutrons. It can be smaller particles that are smaller than protons and neutrons. It could be electrons. And again, let's not get into the physics of subatomic particles. That you're approaching the limit of my knowledge threshold, and I would assume most of yours as well. We don't have to understand what are the particles that make radiation. We just have to understand we're talking about particles moving back and forth as they've been excited, and now they're traveling, right, and they're being emitted. So this back and forth motion of the radiation particles is essentially kinetic energy. These particles have lots and lots of kinetic energy. And what can we do with that energy? And just some fundamentals here of, we don't have to know a whole lot about this, but it's important that you understand these waves move back and forth. These light, just like any other electromagnetic radiation, is being broadcast in these waves. It's moving, these particles are moving back and forth, back and forth. A wavelength is how far is it from the crest to crest, or from trough to trough, from one extreme of that motion of that particle to when it repeats, because they repeat back and forth over and over again. And again, lots and lots of energy available there. So when radiation particles strike another object, whether it's light, whether it's radio waves, whether it's X-rays, whether it's gamma rays, it doesn't matter. When these particles strike some other object, they have all this energy. And when they hit that object, some of this energy that's in that particle is transmitted to whatever it's striking. Plants have figured out a wonderful way to use some of this energy that's in these tiny little particles, a massive amount of energy for their size. There's not a lot of energy there. They've got to collect a bunch of it to put it together to make use of it. And that's what plants have done. Okay, now some things we need to understand about light, just real quickly. We don't have to go into a lot of physics here, but just some basic things to understand. Frequency. I mentioned that term a few times. What does that mean? That is the speed at which a wave repeats. So how long does it take for this particle to move from one extreme through its cycle and back up? So the time it takes for the particle to move from here to here, that is the frequency, and it's measured in how many times does it do that per second, or some per unit of time. There's a unit we call hertz. If you've heard of hertz for frequency, they're referring to how rapidly that radiation is going through this cycle, back and forth cycle, per second. Hertz is per second. So if it's doing this 60 times every second, that's 60 hertz, which is the electricity, the electrons in electricity that you plug into the wall. Those electrons are moving back and forth. That's what we call AC electricity. That's the electricity that you plug into in your walls. That's AC electricity. That is electrons moving back and forth, just like electromagnetic radiation. Those electrons are moving back and forth 60 times a second. That's 60 hertz. Okay? So the higher the number of hertz, the faster these particles are moving back and forth. And so kind of another diagram I just found off the internet, giving you a link here. So when there's a kind of an original author, it's not your textbook, as earlier, I try to give you those links. So this, again, just kind of expanding on, and they're showing you a little, this is not to scale, but they're showing you a graphic representation of it. As you get to these higher and higher frequencies, you notice that the wavelength gets shorter and shorter, and it's occurring faster and faster. Right, so higher and higher frequency, and then they're showing you the frequency scale down here. So higher and higher frequency as you move further along out here. Okay. So again, the visible light spectrum is this tiny little snippet in between what we call infrared and ultraviolet. And so infrared, our eyes can't see infrared or ultraviolet very well, but those are right at the edge of the visible light spectrum, because the visible light goes, it's the rainbow, goes from red all the way up to purple. That's a nice place to stop. We'll pick up the next video here in a little bit. I actually have a Zoom meeting I've got to attend, so I'm going to be running a little bit late today. We'll post these videos. Thanks, guys.